Hi everyone, this is Brian Charles, one of the applications engineers in the applications group. I'm here to talk to you about using variable plunge for selecting a desired spot size based on your solve results. We all have had situations where we have taken a spot and the solve results tell us that that spot is not ideal for polishing the error that we would like to correct. And we have had to go back, set the part up, take new spots, take new metrology, and reevaluate. One way to make that process more efficient is to take variable plunge spots from the beginning. So here I have a spot in my spot browser that indicates here that there are +3 additional spots. And if we evaluate this spot, the initial spot is at the maximum 45% plunge depth, and my secondary spots go down to 33%, 22%, and 10%. We are going to use these spots to evaluate a polishing solve. Initially, if I look at a no variable plunge run, which would be a standard run, and this was taken with the 45% plunge, likely a larger spot than normal, but we're going to use this for evaluation purposes. Here's the initial metrology that we're going to attempt to correct. So in this step, if we look at our solve, we're going to notice a few things right off the bat. First, the removal error map has a very large RMS. It's around 38 nanometers, which is very close to the prediction that we are going to get by using this spot. Second, the velocity map has many spikes and peaks throughout the map, and that is something that we try to minimize in our normal polishing run. And lastly, we are only correcting one asymmetric order. And if you'll notice in the variable plunge setup, I have not enabled variable plunge, so the spot size is the nominal 45% at my largest spot size. And keep in mind that this polishing run is only 9 minutes. If we go to our next variable plunge size at 33%, you'll see that I've enabled variable plunge. I've selected the size of the plunge at 33% throughout the whole part, and I've used the override global variable. And you'll see that there are more spots across the part here than we saw in the 45% plunge depth, indicating that the spot size is in fact smaller. And if we go back to the solve, we have a couple of things to take note of. First, the A-axis velocity map is much nicer, although we do have an additional peak in the center. Second, the removal error map is greatly reduced down to 5 nanometers, as is the prediction map. We're getting down to 15 nanometers rather than a 40 nanometer surface as before. Yet, you cannot get something for free. So as we reduce the spot size, we are increasing the time for polishing in this run. But we are getting more asymmetric orders, 20 on this run versus 1 on the previous run. If we then move to another spot, we're going to go all the way down to our 10% spot and take a look at this one. Again, I've set it up for variable plunge. I've set 9%, 9.6% on all of the spot sizes. And you'll see that the spot size is much smaller and we have more spots across the part. And it's indicated here what the spot size is at a constant 9.6%. Going back to the solve, although the RMS of the removal error map is not that much lower than the 33% spot, and the prediction map is not much different. We do have a much smoother A-axis velocity map, which is preferred for rotational polishing. Again, we've increased the time because the spot has gotten much smaller. So although there are not great differences between the results you may receive, the motion on the machine for the 10% spot may be a lot better. And this is the spot that I would choose to run if I had the time to do so. Again, this is Brian Charles talking about using variable plunge to select your spot size based on your solved results. Thank you very much, and we look forward to hearing from you and hopefully discussing how variable plunge can affect and improve your polishing requirements.